The rubber band stretched tight inside of the can that's attached to either end of the can. Attached to it are 3 washers, which make up the weight inside of the can. Well, you roll it that way, and it rolls even farther in that way. Yay. What I'm doing here is I'm rolling the can around a lot. I'm not just trying to make it dizzy, I actually do have a very good and important reason to do this, which you're about to find out. What's going on as I'm rolling the can is the rubber band inside is getting coiled around itself because of the weight. Since it's only attached to one of the strands of rubber band, what it's doing is, instead of allowing the rubber band to just rotate freely, it's coiling the rubber band around itself, rather like when you wind up the prop on a toy airplane. What's happening as I do this is I'm taking the rotational kinetic energy of the can and converting it into potential energy, which is getting stored as the electric potential in the charges that make up the rubber band. You remember electric potential from earlier in physics. All that I'm doing is adding to that electric potential, which on a very small scale increases the mass and allows for buildup of extra energy to happen in the rubber band. It gets transferred to the can. What happens when I set it down on the floor is I'm going to roll it, which increases the potential energy just a little bit more and adds friction pointing in the opposite direction to get it started rolling in that direction, which releases all the potential energy by converting it into kinetic energy to roll it in the opposite direction. So what happens is the rubber band stores potential energy, which is converted into kinetic energy when the can stops rolling due to friction, and is converted into kinetic energy, which makes the can roll the other way.